Assalamualaikum and good day everyone. In this video, we will learn about chapter 4 entitled Temperature Measurement. Learning outcome. Students should be able to acquire the basic concept, terminology and principle of temperature measurement. And second, students should be able to identify the types of temperature measurement. Next, we move to the introduction. Okay, we know that temperature is most widely measured quantity in process industry. Okay. In manufacturing, the product quality usually closely related with accurate measured and maintained of temperature. Okay, for example, okay, in bakery industry, okay, we need to maintain the temperature so the quality can be maintained, right? Okay, in manufacturing, the product quality usually closely related with accurate, measured and maintained of temperature. Okay, if the temperature is proper measured and maintained, the good quality product will possible. It is also related and the important parameter in the thermodynamic and heat transfer operation like steam raising, gas turbine in power generation and also in numerous propulsion system. Okay, the law that is used in temperature measurement is zeroth law of thermodynamics. Okay, if two bodies are in thermal equilibrium with a third body, then they are all in thermal equilibrium with each other. Okay. Example, the thermometer is calibrated against a standard and is subsequently used to read unknown temperature. Okay, next, we move to the temperature scale. Okay. I'm sure that you all already know. Okay. Common use temperature scales are Fahrenheit and Celsius. These scales are based on specification of the number of increment between freezing point and boiling point of water at a standard atmospheric temperature. Okay, we know from the Carnot cycle, T1 over T2 equal to Q1 over Q2, which is T is the reservoir of heat and Q is the heat energy. Okay, so you have learned before conversion from Celsius to Kelvin and also conversion from Fahrenheit to Celsius. Okay, so Kelvin and Celsius scales are related by T equal to T in Celsius plus 273.15. Okay, next 4.3. Methods of temperature measurement and temperature sensing technique. Okay, first we look at temperature measurement method. Okay. First, non-electrical method, electrical method and also radiation method. Okay. Next, temperature sensing techniques are as follow. Okay, first, changes in physical dimension, which is non-electrical method. So before this, we always use liquid in glass thermometers. So as you can see from the thermometers, there are changes in mercury. Okay. And next, bimetallic thermometers. Okay. Later we will study what is bimetallic thermometers. Next, changes in gas or vapor pressure, also non-electrical method. Okay. First, constant volume gas thermometer and pressure thermometer. Okay, next, changes in electrical property. Okay, electrical method. So the example are resistant thermometer, thermistor, Thermocouple, and Quartz Thermometer. Okay, later in this video, we will learn what is Thermocouple and what is Quartz Thermometer. Next, semiconductor junction technology. Okay, electrical method. The example are by using diodes and integrated circuit. Next, changes in emitted thermal radiation, which is radiation method. The example are total radiation pyrometers and also infrared pyrometer. Okay, and next is changes in chemical phase. Okay, non-electrical method. The example are fusible indicators and also liquid crystal. Okay, thermocouples remain the main temperature sensor, which half of industrial application. Okay, next let's look to bimetallic thermometer. Okay, so what is bimetallic thermometer? Okay, bimetallic thermometer is a thermometer that use the principle of solid expansion and consists of a bimetal strip, usually in the form of cantilever beam. So bimetal means two. So thermometer has two metal. Okay, as you can see from the figure. Okay, so from the figure, bimetallic, we have material A and B, which is A is high expansion material and B is low expansion material. Okay, so A is expand more. So A is faster elongation, example is brass, and B is the slowest elongation, example is iron or invar. Okay, bimetallic thermometer comprises of two metal which having different coefficient of thermal expansion joined together, okay, welded or riveted to prevent the relative motion between it. Right? Invar usually employed as the low expansion metal. Invar is an iron nickel alloy containing 36 nickel. It has coefficient of thermal expansion around 1/20 of ordinary metal and used for measurement of high temperatures. Okay, so that's invar. And next is brass is used as high expansion material for the measurement of low temperature. Okay, real world application. Okay, so what is the real world application? Is a thermostat in air conditioner. Right? So next, another type of bimetallic thermometer is the longer strip of helical form. Okay, so you can see here the bimetallic strip but in helical form. Okay, bimetallic thermometer usually function between -30 to 550 degrees Celsius, and it's commonly applied in temperature control system like oven, electrical iron, and also refrigerators. An advantage is it's self-generating type with low cost with no maintenance, but it has inability to measure rapidly changing temperature. Okay, why? Because it take some time, okay, to get expand. Okay, next let's watch how the bimetallic strip thermometer works. Okay, so as you can see, when heat up the bimetallic strip, the strip got expand. Okay, play again. Okay, working principle of bimetallic strip. Okay, first, temperatures can be measured based on the principle of different thermal expansion of solid. For this purpose, two metal strips, example steel or invar and brass, with different degrees of thermal expansion are firmly joined together. When heated, the metal strip deforms due to the different degree of expansion, and the deformation is a measure of the temperature and can be read on a calibrated scale, okay, as you can see from the video just now. Okay, and then a bimetallic strip brass expand more when heated than iron does and contract more when cool. Okay, as you can see, heat and cool. Because of this behavior, the strip bends as shown. Okay. Next, let's watch this video, the bimetallic Helix thermometer. Okay, as you can see, the bimetallic Helix got expand, okay, and give the reading. Okay, play again. Okay, next slide. Okay, thermometers usage. Okay, bimetallic Helix thermometer usage. The example is oven. Alright, so it is when cool and hot. As you can see, when hot temperature, the strip got expand, okay, and give the reading. Next, application thermostat in oven and refrigerator. Okay, so a thermostat keep temperature constant, found in ovens and refrigerators to keep the temperature hot and cold respectively. Okay, so for example, in oven, heating takes place when the current is on. Okay, when the temperature is too hot, the strip bends away to break the contact. Okay, this is when in oven. Okay, however, in a refrigerator, cooling takes place when the current is on. When the temperature is too cool, the strip bends away to break the contact. Okay, next application is electrical iron. Okay, so this is the component in electrical iron: heating strip, bimetallic strip, temperature control, and fixed contact. Okay, so here is the bimetallic strip. When cool, the bimetallic strip is flat. Okay, as the iron heats up, okay, one of the metals of which the strip is made expands more than the other, causing the strip to bend and break the electrical circuit. Okay, it happened here. Next application is fire alarm. If the fire breaks out, the heat from the fire will cause the bimetallic strips to bend upwards and complete the circuit. Next, the alarm will ring. Okay, so this is the bimetallic switch, and this is the fire detector. Okay, when the fire detect heat, so the strip will bend and touch the circuit. The circuit will be a complete circuit and bell will ring. Okay, next we move to the thermocouple. Okay, sorry. Okay, thermocouple is a temperature measuring device consisting of two dissimilar conductors that contact each other at one or more spots. Okay, it produces a voltage when the temperature of one of the spots differ from the reference temperature at other parts of the circuit. Any junction of dissimilar metal will produce an electrical potential related to temperature. Different alloys are used for different temperature range. Okay. Next, let's see how it works. Two metals join together to form two junctions. One is connected to the body whose temperature is to be measured. This is the hot or measuring junction. The other junction is connected to a body of known temperature. This is the cool or reference junction. Then it will generate different potential that give a value of voltage. Next, the choice of material for thermocouples need to be considered below factors. Okay. First, ability to withstand the temperature at which they are used. Second, immunity from the corrosion. And third one is linearity characteristic. Thermocouple can be broadly classified into categories. Okay. First categories is base metal thermocouples, and second one is the rare metal thermocouple. Okay, so let's learn the differences between these two metal. First, pure metal. Okay, base metal is from pure metal plus alloy of iron, copper or nickel. Okay, but rare metal is the pure metal plus alloy of platinum, tungsten, rhodium and molybdenum. Okay, base metal thermocouple used for temperature up to 1450 Kelvin or 1176.85 degrees Celsius. Okay, and rare metal platinum up to 1600 degrees Celsius, others up to 3000 Celsius. Base metal thermocouple are more sensitive, cheaper and nearly linear characteristic, and it has lower operating range due to low melting point and vulnerability to oxidation. Okay. This table shows the characteristic of some thermocouple. Okay, for increase its sensitivity, thermocouples may be attached in series or parallel, which known as thermopile. Okay, so thermopile is a combination of many thermocouple. Okay, next, advantages of thermocouple sensor. Okay, first, thermocouple bit can be made of small size and consequently with low thermal capacity. In other words, dynamic response of sensor is fairly good. Their cost is considerably less as compared to other thermal sensor, and further, they require no maintenance. Okay, they are quiet, rugged type, so that they can withstand rough handling. They cover wide range of temperature. Okay, and then the output signal is electrical, and they can be used for indicating, recording or microprocessor based control system. Output signal Okay, example, EMF is independent of length or diameter of the wire. They have good accuracy, they have excellent stability, and they can be conveniently mounted in a variety of temperature measurement situation. Okay, but it have some disadvantages. Okay, homogeneity of composition of the thermocouple material and co-working of wires affect the sensitivity of thermocouple. Okay, they require insulation. The output signal require amplification in most application. And by its nature, a thermocouple junction does not generate any thermal voltage when it is in zero temperature. Thermocouple widely used as temperature measurement for gas turbine, exhaust, diesel engine, and as flame sensor in safety devices for gas power major appliances. Next, we move to the quartz thermometer. Okay, or we call it piezoelectric crystal. Okay, provides a highly accurate and sensitive method of temperature measurement based on the change in its resonant frequency. Okay, which is directly proportional to temperature change. Okay, so we use quartz to measure temperature. Okay, and use its change in its resonant frequency. Okay. To achieve above properties, the crystal is cut in the form of shear type LC cut. Okay, like this. The detection of change in frequency of oscillation of 1 Hz give a resolution of 0.001 degrees Celsius. Okay, 1 Hz give 0.001 degrees Celsius. Thus, temperature in the range of -40 to 230 degrees Celsius can be measured precisely and accurately. Okay. So this is how quartz LC shapes looks like. Okay. Basic principle. Okay. Air molecules collide with thermometer. Their energy is transferred to mercury inside. Okay. So when it moves, it has kinetic energy, right? So when it's cool, less kinetic energy. So air molecules move slower. In cool air, mercury doesn't rise. Okay. But when it warm, okay, it has more kinetic energy, and the molecules move rapidly in warm air and causing mercury to rise. Okay. So a crystal oscillator is an electronic oscillator circuit, okay, that use the mechanical resonance of a vibrating crystal of piezoelectric material to create an electrical signal with a precise frequency, and this frequency is often used to keep track of time. Okay, so there's dynamic force, and then this is the quartz crystal. So when it moves, it will give the resonance. Okay, and then the resonance will give the electrical signal. Okay, so what frequency does quartz resonate at? Okay, the quartz crystal use vibrate, okay, with frequency of 32,768 Hz. Okay, and next, what is the period of the crystal motion? Okay, so we know that period, okay, equal to 1 over frequency. So the period is 30.5 microsecond. Okay, next. What is the advantage of piezoelectric? Okay, it has highly linear input. Okay, long-term stability and reliability. High resolution of the order of 0.001 degrees Celsius, and also has excellent repeatability in the measuring range of -40 to 230 degrees Celsius. Okay, however, it also have some limitation. The first one is the limited measuring range from -40 to 230 degrees Celsius. Piezoelectric crystal have strong cross sensitivity for pressure changes if they occur simultaneously in the temperature measuring system. Okay, so that's all for chapter 4. If you have any question, okay, you can ask me. Okay, thank you for watching. Good luck and Assalamualaikum.